So we know that distance is important, and I explain you guys some example of, okay, I want to be close to my suppliers, I want to be close to my customers, and distance is important. So this this is I'm going to show you guys now is are two ways of calculating distance, right? So okay, I have 10 suppliers, they're in different places. Where exactly should I put my plan, right? Or I have 5 distribution centers that I have to supply to, and from my plan to those 3, and then where exactly is the best place to put my facility. Okay, so we're going to learn 2 methods to calculate distance. So imagine that you have for example, 3 major retail facilities. So we have C1 that we supply, we have C2 that we supply to, and we have C3 that we supply to, right? And here the red one is where I'm planning to build like a centralized location. First, what I'm going to tell you guys how to do is how to calculate the distance between those points, right? And here we have in the table X and Y axis, but you can think about longitude and latitude. Actually, we use this very often, this low distance method in capstone consultant projects. We did one with Sunoco where we plan what warehouse should they use and where should they put the warehouses in the East Coast for the 5 states on the Southeast Coast for their 3 different business products. So Sunoco is a big packaging company, the largest private company in South Carolina, uh, and and then we that's what kind of we did for them. So we use this method, and there's 2 ways to calculate. One, you can calculate the Euclidean distance, which is straight lines, or between those 2 points, it's the shortest path. So it's just the diagonal, the straight line between 2 points. And the other one is the rectilinear distance, which is I take only 90-degree turns. So I either go down or up or right or left. And then with 2 lines and a 90-degree angle, I can get from any point to any point. So I'm going to learn how to calculate that. I think this image show you guys better what I was trying to explain. Very difficult to explain in words. So imagine that C1 is here, and that's 318 because X is 3. Okay, 1, 2, 3. And Y is 18, right? That's why it's 318. And this is C2 is 6, 5. Okay, so that's the coordinates. So we have to go from 318 to 812. Okay, and here what we're doing is Euclidean distance, which is the straight line. So the straight line distance between those 2 points is calculating by the diagonal of a triangle. So imagine that you have a triangle here, here, and here, right? And then I use the formula to calculate the diagonal. If you guys are on top of your geometry, you will know that this is the Pythagorean theorem, right? Remember guy named Pythagoras or something like that. So Pythagorean theorem, and then we can use that to calculate the distance. It will be the square root of this, square of this plus square of this, and then you square root everything. So it'll be xa minus xb, so it'll be 3 minus 8, plus ya, so that's 18, minus yb, which is 12, right? We do the math and we get to 7.81. Okay, so that's this distance here. I can also calculate the distance between those 2 points doing the sides of the triangle. Okay, so then I will do this plus this one. Okay, instead of doing the diagonal, the Pythagorean method there to calculate it, the Pythagorean distance there. And then here, this case is going to be 3 because that's xa, so 3 minus 8, the absolute value, plus 18 minus 12, the absolute value. and this give us the distance of 18. So there's no right method or wrong method. There's two methods to calculate the distance. So you guys have to pay attention because sometimes the problems will tell you to calculate rectilinear distance, and sometimes they will tell you to calculate the Euclidean distance. So you have to pay attention what method the problem is telling you to use.